This term, as you know, we are looking at measurement. So the first lesson today, we're going to look at the concept of area, nets, and which leads us into surface area. So if you haven't yet done so, please make sure that you go into the lesson and you download the notes to go with video 1, and as you will need that as you watch this video. So these are the notes. Feel free to read through the notes, and there are some examples, and you'll see that most of them are blank. Feel free to have a go and fill them out. Pause the video, give them a go, and then you can play the video again and check your answers. Okay, we're going to look at area first. So the area of a 2D shape is the amount of surface or flat space within the boundaries of the figure. So the typical sort of area formula you'll probably be aware of is the area of a square. It's length times length, so area is length squared. A rectangle is length times width. A triangle is a half times the base times the height. And then you've got some other ones here, the rhombus, the parallelogram, and the trapezium. These formulas you may or may not be aware of or be so familiar with. Another formula for area, which is a very common one that is used, is the area of a circle. This is pi r squared. Pi is on your calculator, so you need a scientific calculator for this topic. If you can't find pi on there, you should be able to, but if you can't find pi on there, you can use the number 3.142 instead for pi, but see if you can find pi on there. So we're going to have a go at the first example, converting. We're going to, example 1 says convert between 500 millimeters squared to centimeters squared. So convert 500 millimeters squared to centimeters squared. Now, when converting between areas, we use this conversion up here. So we're going millimeters squared to centimeters squared. We divide by 10 to the power of 2. Or in other words, divide by 100. So 500 millimeters squared. To get to centimeters squared, we divide by 10 to the power of 2. Which gives us, you can do that on your calculator, you can do that in your head, it will give you 5 centimeters squared. So we're just going from here to here. Make sure you include the units. And the other way, if we were going from centimeters squared to millimeters squared, you'd times by 10 to the power of 2. And then you've got the other conversions here as well. Okay, let's have a go at the next question, question number 2. Find the area of the following shapes or composite shapes. In this case, in A, we have a 2D shape, which is a circle. And you can have a look on the previous page if you don't remember. The area of a circle is pi r squared, where r is the radius. In this example here, we're given the diameter. So the radius is just half of that, half of the diameter, which would be, the radius is 1.5. That there would be the radius. So we just put that into the formula, pi times 1.5 squared. And you put that in your calculator, and you get 7.07. We're just going to answer these to 2 decimal places. Now, for area, you should always put units. So in this case, it doesn't have 3. Doesn't say what unit it is. It doesn't say it's centimeters or meters, etc. So I'm just going to write units squared, okay? Because it doesn't tell me what particular units there are. So area is the units is always squared. B, this one here. If you have a look at the on the previous page, if you look back here, that is an example of a trapezium. So you've got the 2 slants. You've got the height, and these lines, these double arrows, by the way, because you've got two arrows here and 2 arrows here, that means they're parallel. These 2 lines are parallel to have a trapezium. So we use this formula here. So a half A plus B. A is 1 is the top, B is the bottom, so 0.7 plus 0.9, and H stands for the height, which is what you're given there, 0.2. So we put that all into our calculator, and you get 0.16 centimeters squared. Give that one a go and make sure you can get that on your calculator. And again, don't forget the units. Okay, part C. C is an example of a composite shape. So a composite shape is a shape that is made up of 2 or more different parts. So we're going to split this shape. I can see I've got a triangle here and I've got a rectangle down the bottom. So the area of the composite shape is area 1 plus area 2. That's the total area. I can again further break that up and write that as area 1 is a triangle. So it's a half times base times height. And area 2 is a rectangle, so it's length times width. It's very important to make sure you show all your working in a measurement question. So the triangle, the top part, the triangle, half times, what is the base? The base is 21 because that base 21 is the same as that base there. So it's 21 times the height. Now the height of the triangle is that distance there, the height. Put the height in. Now we're not given that explicitly, but we can get that from the diagram. This whole distance is 32. That distance there is 16. So we can work this blue part out by subtraction. It's just 32 minus 16. Which equals 16. Times by 16. Plus, so that's for the triangle. So that's for the triangle part, the top part. Then for the bottom part, which is a rectangle, it's 16 by 21. That's the formula. So length times width. We can then work that out. So a half times 21 times 16 is 168. Sorry about that. Plus 16 by 21 gives us 336. And if we add that together, that gives us 504. And the units, it's centimeters, and because it's area, it's squared. Okay, let's have a look at the next one. Okay, now we're looking at surface area. So when we have a solid, a few terms first. When we talk about a solid, we're talking about a 3D object. So in this example here, we have a cuboid. You could have a cylinder. You could have a pyramid. Okay. When we want to find the surface area of a solid, what we are looking at is we're looking at all the faces. So you can imagine if you had, for example, say this shape here, which is a cuboid, and you needed to cover it all the outside with wrapping paper, you could say to yourself, how much wrapping paper would I need? How much of that outside surface would I need to cover? So a good idea is when you're trying to work out the total surface area is to first of all count how many faces you have. So for example, in this case here, I can see 1. I can see this one here, the side, 2, and I see the top 3, but I can't see the other sides. They are there though. You can see them because I can sort of see them because it's see-through. But there's 1 at the back here, 4. There's 1 at the bottom here, 5, and there's 1 behind there, 6. So there's 6 faces. So you need to make sure you count all of them. One way to make sure that you do count all the sides, and particularly when it's not something like a cuboid where it's so obvious, is where you have something like when you use something like what we call the net of a shape. So we have a look. If you go back to this the lesson here, there's a file here that says extra examples, nets of 3D shapes. You can open that file if you like. And there what you will see are the different nets of different shapes. So for example, a cube, if you were to open it up, you would get the net, which is drawn like this. So there's 6 faces, 12 edges and 8 vertices. A cuboid, which is the one we just saw, you could open up, it would look like that. That's the net of it. A cone, if you were to open up a bit more trickier, the net would look like this, etc. So I'm not going to go through this whole document. It is in the lesson, but you can go through and have a look at all the different nets. And this will actually help you with one of the activities you're going to do in the worksheet. So that is found in the lesson here. All right, let's go back to the worksheet. All right, so this question here says, find the surface area of this cuboid. So I'm actually going to do it first of all without using the net, and then we're going to use the net. So we'll do it 2 different ways. You can pause the video if you like and have a go at finding the surface area before I do it. All right, so the surface area, SA, stands for surface area. Sometimes you'll see TSA, so T at the front, just meaning total surface area. So what do we know from this? Well, this side here is a rectangle. We have a rectangle at the top and we have a rectangle here. They're the parts we can see. But I also know that this rectangle is replicated on the other side. This rectangle is replicated on the other side, and this rectangle at the top is also replicated at the bottom. So it's double of everything. So let's look at this side. So 3 times 2, length times width is for this area. And there's 2 of them because there's the other side on this side that we can't see. Let's look at the top. The top is 2 by 4. So we add, there's 2 of them because there's also the bottom. So 2 by 4 plus this side here, which this rectangle here, which is 3 by 4. And there's 2 of them because there's the one behind that we can't see, right on the reverse. And if we can work that out in our head, or we can use our calculator, we end up getting 52. And if we get the units, it's centimeters squared. Now, if we want to use a net to, we can draw a net, we can draw it, or I've actually got a applet here that you can click on and have a look at. I've already opened it, so let me go to this applet. It's here. And this is for a cube or cuboid. So I'm just going to untick these first, and I'm going to put in the measurements. The first one is the length from that example was 4. The width from that example was 2, so you can alter it. And the height using these sliders, the height using this slider, I can change it to 3. So that's the cuboid we had. It doesn't look exactly like that because it's rotated, but it is like that. So I can then show the net, and you can see it's color coordinated, so that's quite nice, and it shows the measurements. So if I was to open this up, that's what it would look like. So you can see these 2 are replicated, the purple's the same, the pink's the same, and the green's the same. You can then also click hide show surface area, and it gives you the calculation, which is what we just did. You can now have a go at the worksheet, which is in the lesson. You'll notice that it says there's worksheet for today, lesson 1 is a Word file, worksheet for today, lesson 1 is a PDF file. They're exactly the same. Just click on one of them. They're just uploaded in 2 different formats in case you can't see the Word file.